of nucleophilic alkyl substitution reactions, we've got a different way of making alcohols, and we're going to make alcohols through nucleophilic acyl addition reactions. So fundamentally, there's a set of reagents that are covered in this chapter that deliver either a negatively charged hydrogen or a negatively charged carbon. So there are these two, borohydride and aluminum hydride. And these are hydride reducing agents. Which are sources of H minus, right? So not H minus directly, but they're sources of hydrogen that comes with a pair of electrons, so nucleophilic hydrogen. Right? Normally hydrogen is a proton, so normally hydrogen is electrophilic and is attacked by a lone pair, but these are sources of nucleophilic hydrogen. And the reason for that is because boron and aluminum are both in group 3, right? Group 3A atoms, which means they don't really want a filled octet. They want a filled octet, but when they have a filled octet, they have a negative formal charge, and they're not very electronegative elements, so they don't really want the negative formal charge either, which means they're happy to ditch one of these hydrogens with its pair of electrons. Right? The other reagents that we are going to see are alkyl lithiums and alkyl magnesium bromides. Right? So this is an alkyl lithium, and this is an alkyl magnesium bromide, or a Grignard reagent. Named after, it's one of the few reactions that's named after a Frenchman. Most of them things were done in Germany and Russia. Right? So these are sources of C minus. Nucleophilic carbon. And you haven't seen sources of nucleophilic carbon before, because most of the time carbon is going to be attached to an electronegative element like oxygen or bromine, which means carbon is going to have the partial positive. But in this case, since lithium is much less electronegative than carbon, the dipole goes the other way. Oops. And you have the partial negative on the carbon. Same here, partial negative on the carbon, partial positive on the magnesium. These are relatively covalent. The alkyl lithium is about 40% ionic, and the alkyl magnesium bromide is about 35% ionic. So they're not as strongly basic as like a CH3 minus would be if it was attached to potassium, for example, and you don't have that good overlap. Pretty good orbital overlap since they're both similar size, lithium and carbon, lithium plus and carbon. Right? So sources of C minus and sources of H minus. Borohydride and aluminum hydride are the sources of the H minus, and lithium and magnesium salts are the sources of the C minus. And these can be made by adding the alkali or alkaline earth metal directly to a haloalkane. So the most common ones are alkyl bromides and iodides. But alkyl chlorides will also work, just more slowly. Questions so far? So we're looking at reagents that will deliver H minus or C minus. So they'll deliver that hydride, that H minus or the C minus from an organometallic reagent. Other metals are possible, but for now, just lithium and magnesium. All right, so a hydride reducing agent or the C-, they deliver them to a carbonyl group. So a C double bond oxygen with something attached. It could be hydrogen, could be two different R groups. And the key to understanding the reactivity is to remember that there's always a minor resonance contributor for a carbonyl group that has a positive formal charge on the carbon, which means that this carbon is electrophilic. So we're going to be donating the hydride, the H- or the C- to the carbonyl carbon. And then there's an acid workup step after the initial reaction. In most cases, borohydride is the exception. So almost always what you're going to see is you're going to see a two-step reaction, and it's important that you write them as two steps. Where in the first reaction you'll have lithium aluminum hydride, and that has to be run in a inert solvent. So diethyl ether is common, or THF. THF is basically diethyl ether but in a ring. Those are the two most common kind of inert ether solvents. And then in the second step, there's a separate aqueous acid workup. You can't have lithium aluminum hydride in aqueous acid, or all it will do is deprotonate the water, form hydrogen gas, and generate enough heat to ignite. So you've got to make sure that this step is done before you add the acid. The intermediate is an alkoxide ion. With the lithium salt there. And then the acid protonates that to generate the final product, which in this case, because I started with an aldehyde and with a hydride reducing agent, I get a primary alcohol. So the starting material and the product differ. What type of alcohol you make depends on what starting material you start with. But in all cases, you're with a source of H- or C-, and the alcohol is a product.